In this video, we are going to solve some problems based on electrical quantities. So the first problem, in the diagram below, the current in the 5 ohm resistor is 3 ampere. What is the potential difference between points A and B? So we are going to use the formula for voltage, V equal IR. The current is given to us. We want to find what's the resistance. It's a series circuit, so our total will be 5 plus 4, which is equal to 9 ohms. The current is given to us as 3 ampere. In series, the current remains the same. So for both the resistors will have 3 ampere. And we can find the potential difference across A and B by multiplying 3 with the total resistance, which is 9. We get it as 27 volt. How much charge passes through the wire during the interval 0 to 4 seconds? And they have given us a function for current, which is 3t square minus 2t, where I is measured in milliampere and t is measured in seconds. So we are going to use the formula for charge, which is integral I dt. So we'll substitute the function, use the limits 0 to 4 and solve the integral. When you solve it, you will get the answer as 48. Now for units, we can see that they said that I is measured in milliampere. That means the unit for charge should be millicoulomb. Now we have got another problem here. There are no numbers given to us. Two conducting cylindrical wires X and Y are made of the same material. Yx has twice the length and twice the cross-sectional area of wire X. So let's just write down wire X and wire Y. They are having same material, so their resistivity will be same. The length of wire X, if we say that the length of wire X is L, wire Y will be 2L because it's twice the length of X. If area of cross section of wire X is A, then the area of cross section for Y should be 2A because it's twice the cross sectional area of wire X. Now we can use the formula for resistance just to get an expression. For Rx will be rho L over A. For Ry it will be rho 2L over 2A, but 2 can be cancelled out and we see that it is same as that of X. So when we find the ratio, it will come out to be 1 because both the resistance for wire X and wire Y, they are equal. Next problem. The resistor is 0.2 centimeter long and the cross section and has a cross sectional area. So we have got the length given, which is in centimeter. We'll convert that into meters. Area of cross section given, which we'll write down, A equal to 1.6 times 10 to the power negative 6 meters square. Resistivity is also given to us. The question is asking us to find what's the current. So for current, the formula is V over R. But resistance is not given to us. So first we'll find the resistance using rho L over A. That's direct substitution. Get the value for resistance. Substitute that into the formula for current and you will get the current as 0.48 amperes. Next problem. What value of R will produce the indicated currents? So we have got a circuit given here. There you have got the current in 2 branches. So, and there's also R written for 2 resistors and we don't know what's the value for R. We know there is branch 1, there is branch 2, it's a parallel circuit. So the same voltage will be there for each branch. So V1 is equal to V2. V1 means the voltage across branch 1, V2 means the voltage across branch 2. So I can write that as I1 R1 equal I2 R2. I1 is 2 ampere. So 2 times R plus 20 because in branch 1 you have got 2 resistors, they are in series, so R plus 20. I2 is 4 multiplied by the resistance we don't know, that's R. We can solve it for R, we'll get the answer as 20 ohms. Next problem, a battery has a voltage of 50 volt and when it is not connected to a circuit, that means we have been given the EMF, which we'll write as E equal 50 volt. There is an external resistor 20 ohm and the current is given to us as 2 ampere. It's asking us to calculate what's the internal resistance. So from the formula sheet, you will see the formula E equal IR small r plus I capital R. E is the EMF, I is the current, small r is the internal resistance, capital R is the external resistance. So we just substitute the numbers here, only small r is missing. We can solve it for small r, we'll get the answer as 5 ohm. Similar kind of problem here. So here also we will use the same formula. We have been given what's the voltage for the battery, the current is given to us, and the internal resistance is missing, external resistance is given to us as 9. We can solve it for small r, which is equal to 3 ohm. Okay, next problem is based on series and parallel circuit. So we have got a circuit with 3 resistors. It's connected to 120 volt battery. It's asking us to calculate in the first part what's the resistance or equivalent resistance for R2 and R3. Equivalent means total resistance. So they are connected in parallel. We'll use the formula for parallel. We'll get the answer from the formula as 1 over 40. Then we need to flip it to get the answer as 40 ohms. Now it's asking us in part B what's the equivalent resistance of the circuit. That means now we want to get all the 3 resistors, what's the equivalent resistance. So we'll redraw the circuit. I have replaced R2 and R3 with its total resistance, which is 40 ohm. Now we can see that 20 and 40, they are in series. So that will just add up to give you 60 ohm. Then it's asking you what is the total current in the circuit. Total current formula is V over R total. We already got R total, which is 60. V is given to us, which is 120. We get the answer as 2 ampere. Then it's asking us what can you say about the current in R2 and R3. We can see that both R2 and R3, they are connected in parallel and they have the same value of resistance. That means the current in each one of them will be same. So R2 and R3 will have same current as they have same resistance. We know that the total current we found as 2 amperes. So when it reaches to the junction, it will split into I2 and I3. But because R2 and R3 have same value of resistance, it will split equally into 1 ampere each. That means that same current will be 1 ampere.